Hello everyone, this is the 5th video in the integral and derivative series. In this video we're going to be learning the integral of ln x. So you may have noticed I deliberately sort of left that out of the other video with the special functions because we didn't quite have the tools to tackle that yet. But now that we know product rule, chain rule, quotient rule, you can sort of differentiate anything. You can't integrate anything though. Now we have integration by parts. So integration by parts, or IBP for short, is this formula right over here. And I know it looks daunting at first, so I'm going to break it down. All it's saying is if we have the integral of u, some function u with respect to x, times another function, which we call v with respect to x, dx, okay, that is going to be equal to the first function multiplied by the integral of the second function minus the integral of the derivative of the first function times the integral of the second function. So to solve this problem, we're going to establish what is the first function and what is the second function. The first function we want to differentiate, the second function we want to integrate. In this scenario, it's very obvious because we're trying to find out the integral of ln x. Obviously, ln x has to be the first function because we don't know the integral of ln x. It can't be the second function. So if I say u equals ln x, du is equal to 1 over x dx. So what I did here was I just differentiate both sides, right? The derivative of u is just 1, right? This is really 1 times du. And the derivative of ln x is 1 over x, and then we multiply it by dx. Okay? Nothing too hard. Here, we're going to have dv equal to dx. So this is what I want to integrate. When I say dv to something, that just means I want to integrate it for the integration by parts. I want to find v, right? V is what I want to find. So v is going to be equal to the integral of dx, which is just x. So these are the three things that we need. Okay? Now we're going to build our integration by parts over there. So we're going to start with u, which is ln x, the integral of v, which is just v, so x, and then we're going to subtract the integral of 1 over x, right? That's the derivative, dx, and then the integral is x. So I should have wrote the x first there, 1 over x dx, like that. These are obviously going to cancel out. And we know that the integral of 1 is just x. Don't forget your plus c. And here we have the solution. So this is sort of how to use integration by parts and what the derivative of ln x is. Now you can memorize this. This is pretty helpful. You don't have to go through these steps every time. But integration by parts is not just used for this. It has many use cases. So still know how to do it. And the more you do it, you don't have to memorize this formula over here. It'll become natural. You'll just choose one function to differentiate, one function to integrate, and it's usually very obvious because you don't know the integral of one of the functions most of the time. Now in this case, we sort of got easy, right? dx was our other function. What if I gave the integral, one moment, I'm gonna just delete all of this. Right, what if we had the integral of x e to the x dx? Now we have an actual thing. Okay, how do I choose? I know the integral of both, I know the derivative of both, but what makes more sense to differentiate? I know the derivative of e to the x is just e to the x. Is that really going to help me get anywhere? Not really. But the derivative of x is 1. It essentially eliminates it, right? In this part, this is just going to be 1. And we're just going to be left with e to the x. And we know the integral of e to the x. Therefore, that's what makes the most sense. So I'm going to say u equals x, right? Du equals dx. dv equals e to the x, dx, right? It's both of these. Keep in mind, it's not just e to the x, it's e to the x dx. Very crucial that you remember that. V is equal to e to the x, right? Just by integrating both sides, just like in the differential equations video, right? Okay, so we've established this. Now let's go into building. So we have u equals x. We have v, e to the x. We have, oh yeah, I want to write it like this actually, because you might see it like this more often in textbooks. Okay, this is just sort of what I'm doing in my head. It's a cleaner version of the formula, that's all. Anyway, where was I? Right, e to the x, and then here we have x, sorry, dx is what we have. Okay, we know that this is just going to be e to the x, so we can factor that out. We'll get this. And that is our answer. So, if you guys did enjoy it and you learned about integration by parts, super powerful tool, okay? And next time we will do u substitution.